Hey class, welcome. Today we're going to be talking about security zones. Now, in Palo Alto Networks firewall, zones are a fundamental concept in the networking security policy enforcement. Zones pretty much define logical groupings of interfaces, okay, and are used to enforce security rules. Traffic between different zones, right? You have one zone, another zone, must be explicitly allowed by the security policies. So your security policies are the rules that will say, hey, this can talk to this, or this cannot talk to this. All right. While traffic within the same zone is typically permitted by default. All right. I mean, you can go more granular and be very micro ruled of what within the zone of what can talk to within, but we're just going to be talking about zone to zone, right? One environment to another environment, right? Now, let's see. Let me scroll down here. The security zones we're talking about. Now, the purpose of security zones are pretty much for network segmentation. You know, the use network segmentation to secure access to data, right? It's a fundamental concept of zero trust architecture, which kind of goes beyond the scope of this class, but it's a really prevalent topic within the security community as of right now. Now, network segmentation, like I mentioned, it's pretty much considered as zones within Palo Alto firewall security zones. Now, the drivers of different security zones include who must have access to what, use a principle of least privilege, and consider any regulatory requirements, right? Within a security zone, you want to keep like rolled jobs in one zone and other like rolled jobs, systems, users in another, right? You can have different security zones, whether it's account, network, whatever it is, right? It pretty much just regulates who has access to what, right? So for example, in this picture right here, accounting and sales can have access to customer contact data, but only accounting can have access to the credit card data. Sales cannot have access to the credit card data, right? And in another example, in the external web applications, customers can access external web applications, same with HR, but only HR has access to employee information, right? We're doing segmentation, right? We're creating those zones to ensure only the right people get access to what is needed. And that goes again with the use of the principle of least privilege. Now, using zones, it reduces the attack surface because not everyone has access to all the zones, I guess. So zones is going to be probably one of the most overused words in this video. But pretty much when you allow to block by default other zones from accessing a specific zone or users or groups, then, you know, by default, you're limiting that access, potential vulnerabilities, potential unauthorized access, escalated privileges, whatever it is, right? Now, in the Palo Alto environment, when you log into the Palo Alto firewall, you'll see your policies, your security policies, the source and the destination in the zone area. You pretty much tag and label what zones are connecting to which zones. So here it says Bob in the B2B zone is allowed access to the PCI zone, right? This is a security policy specific. So when we say security policy, it's more so, it's not like a written policy. In the firewall, in the Palo Alto world, it's more so around what are the firewall rules. Bob can access the PCI if he is coming from B2B, right? Otherwise, probably going to be blocked. Even if Bob is the same user, if he's not the source from B2B and he's trying to access PCI, then he will probably be blocked. This is very specific. It says specifically from B2B he can get to PCI, but anywhere else, nope. All right. And then any other inner zone traffic is blocked by default. You'll see here, down here, this last firewall rule, inner zone default, deny by default. Okay. Now, a couple things I really want to touch upon is the source zone. This is just based on the ingress interface. The destination zone is determined by the routing table, and the egress, what's coming inwards. And then the security policies, like I mentioned, is a firewall rules that match traffic against the configured policies, decide whether to allow it or deny it. You'll see here the action it will take on this, the very last column, allow or deny. So key points about zone and interface mapping. And we'll go more into interfaces in a little bit, but just some key points I want everyone to know. One zone can have multiple interfaces. Actually, let's just scroll down here. It might be easier. Interface types and zones. You can assign multiple interfaces to the same security zone. This is useful when you want to group multiple network segments under the same security policy. Okay, so if you have multiple network segments that are subnetted out, and you want all of them to be in one security policy or firewall rule, so you don't have to create multiple, you can kind of group those subnets into a zone, right? Or you take one zone, have multiple interfaces associated to it, each interface a different subnet, and create one policy. Okay, so you're gonna have to think back to your networking, right? CISS N340 and 341, right? In addition to that, you can have one interface to one zone, each interface like a one-to-one relationship. You can have each interface only be associated with one zone at a time. You cannot assign the same interface to multiple zones. So that's one thing very specific that you have to know. You can have one zone assigned to multiple interfaces, but only one interface can be assigned to one zone. And then you have zone-based security enforcement. The firewall evaluates traffic based on the source zone, interface where traffic enters, and destination zone, interface where traffic exits. I apologize, I swapped those. Source zone is where the traffic exits, destination zone is where the traffic enters. And then there's also the no default zone. The no default zone, which we brought up here real quick. This no default zone, interfaces must be explicitly assigned to a zone. Okay, otherwise they belong to a no zone category, and traffic will be dropped by default, which is this deny by default firewall rule down here. So in general, a zone must be assigned to an interface. It must be assigned to an interface. Interfaces can only belong to one zone at a time. All right. Now, in addition to that, traffic between different zones require an explicit security policy. By default, inter-zone communication is denied. Traffic within the same zone is allowed by default, but can be restricted. Go more granular. Each interface in a virtual router must be assigned to a zone, must have a zone assigned to it, and zones are independent of IP subnets. A zone can contain multiple interfaces with different subnets within that zone. Okay, so that kind of summarizes all the zone and interface situation. Okay. Now let's move on. Let's talk about zero trust. So zero trust is pretty much just verifying before implicitly allowing, right? Just because this person is within a secure zone doesn't mean that they should immediately be allowed. Or, for example, just because you are logged into your computer and you are connected to a secure, safe work Wi-Fi or work network at your work, it doesn't mean that your work is going to explicitly allow you to get access to everything. Okay? You still have to verify who you are. You still have to log into your accounts, right? That is what like zero trust architecture kind of broadly is. Verify, even if you're in a very safe, secure environment, just because you're in there doesn't mean you could be a bad person, right? It doesn't mean that, what if there's an insider threat, right? Within a secure area or within an environment that is secure, right? We have to verify each and individual person, because just because they're inside a secure zone doesn't mean they're going to do bad things, right? So we have to always verify, never implicitly trust. That includes the inbound traffic and the outbound traffic. All right. Now, zero trust architecture is pretty broad. There's a lot of different security controls. From a networking and from a firewall perspective, we're just saying here about the zones specifically. You always want to do north-south inspection, even if it's coming from a security zone. You always want to inspect the inbound and outbound traffic, which is going to happen at the edge of the firewall. And then also you want to inspect east-west traffic, right? East-west traffic is between different security zones, and you'll hear east-west traffic come up quite a bit because it's still something that is a little difficult and hard to track. And there's more companies and vendors out there that are creating specific dedicated tools to do that east-west traffic, right? How to monitor traffic between different networks within your environment, different security zones within your environment. Palo Alto does some good east-west traffic monitoring, but the concept of zero trust is just because in here the user zone and the application zone are both within your environment, and doesn't mean that both zones are secure and safe and that they should be able to talk to one another freely, right? We still have to inspect, what if the user zone was compromised, right? And it wants to talk to the application zone. It's going to compromise the application zone. So you have to make sure that we are, in a sense, verifying that each user going back and forth within the environment is verified. Okay. We already went through some of the interfaces. We talked about different zone types. So there's different types of zones. There's a trust zone. Trust zones are typically used for internal or trusted networks, like a local area network. There's an untrust zone used for external untrusted networks, like the internet. So I think we can see here, go back here, internet zone, right, untrusted. The DMZ zone used for public-facing servers, all right, such as web or email servers. And then there's a VPN zone used for VPN traffic. There's an external zone for third-party connections, cloud providers, or partner networks. Okay, so for example, you have some cloud-based software or application that's hosted by someone else, and it needs to directly come into your environment, right? That's kind of like an external zone. And then you have a virtual wire zone used when the firewall is deployed. It's transparent, layer 2 mode. All right. Now let's continue on. And before we move on, I apologize. I want to go over one more thing. We're looking at these security policies, firewalls, right? Firewall rules, also access control list or conditions. Just a quick reminder, security policy rules are evaluated from the top down. So the firewall will check this rule 1, and then if it doesn't meet that condition, it'll go down to the next rule. It'll check if it meets that condition. If yes, then cool, allow, stop. But if it doesn't meet this condition, then it goes down to 3, then 4. 4 is the last one in this specific example, and then I'll just deny it by default, right? So it is very important that you order your security policies or your firewall rules in order. One change in order can completely cause an outage and mess up your whole environment. For example, if 1 was 4 and 4 was 1, right? Let's just say if the deny by default is security policy or rule number 1, then everything will be blocked, because the first check that the firewall will do is block everything immediately, right? And then it won't get down to the rest of the security policies. So the order is super, super important. You set the rules, prioritize them. If one condition is met, then it moves on to the next action. So just remember that. So now let's go into interface types real quick. Not going to spend too much time on this one, but Palo Alto Networks firewalls can integrate into networks using different interface types. It all depends on deployment needs. So every organization is going to look different based off of how their organization environment is set up. So there's not one rule fits or size fits all. There's 3 different deployment options. There's the tap mode, where it connects to a switch's mirror or span port to monitor applications without changing the network. It provides visibility only, not traffic blocking. So pretty much what it does is you have your switch, and there's an interface on the switch that whenever there's traffic coming in, it kind of duplicates it and copies it and sends it out to the firewall right here, right? It sends it out to the firewall in addition to sending it down the environment and network, right? But the firewall will do some monitoring and analysis, but it won't actually take any action, block, or you can hit any security policies through it. It just kind of monitors. It's used for evaluation or auditing. Whenever you do a security assessment or a pen test assessment, not pen test, but like whenever you do an assessment, more on a technical base, that's how they'll assess the traffic that's coming in and out, monitoring by using that mirror or span port. Now, the second type is virtual wire. Virtual wire inserts the firewall in line without requiring address changes or topology or redesign. It supports full protection, decryption, and NAT. It just kind of looks transparent. Okay? It does include NAT, network address translation capabilities. But something to specifically for this one is that it sits behind your environment's firewall. So there's a firewall and then the Palo Alto right behind it. So whatever comes through your firewall, then the traffic will go to the Palo Alto. It does seem a little redundant, but sometimes it's used for specific things, because you may buy specific modules for Palo Alto. You may not use every single module, so you may need that extra layer in defense. So it sits behind the firewall. It doesn't change your networking addressing. It's just behind it, but it can take actions, including like doing some protection, encryption, decryption, natting, etc. And then the final one is layer 3 mode. You pretty much just replace your environment or your organization's firewall. You have that Palo Alto sit as your edge firewall. All right, it handles routing, full security functions, and a key advantage is flexibility. So you can mix and match to whatever the interface types For example, TAP for monitoring one segment and virtual wire, or layer 3 for others. Now let's continue on. Something to know about the TAP interface, the TAP mode, it's very passive. It's just for monitoring. I believe I mentioned that. So let's continue on. And down here, it kind of goes through the different steps you'll take through your NetLabs and how to configure TAP interfaces. And here it goes through, the next slide, it goes through the virtual wire interface. I guess it's also called a bump in the wire or transparent inline deployment because it sits right behind your firewall. Your firewall is, those destination and source IPs. It's just right behind it, but it can also kind of act as a default gateway for your internal environment. It goes to the Palo Alto. Palo Alto speaks to kind of like a proxy in a sense. And then it goes directly to the firewall. A virtual wire cannot be a termination point for an IPsec VPN tunnel. That's something good to know. And then here it will go through the different how to configure it. Layer 3 interface. So this is specifically something to note. Actually, I'm going to go back real quick. One thing about this virtual wire interface is because it's not on the edge, it cannot do routing. All right. However, if you use layer 3 interface, it can actually do routing between multiple interfaces. So Ethernet 1 and Ethernet 2 can talk to one another. It will require network configuration to accommodate new IP addresses. It is a little more complex. But having a firewall and then Palo Alto right behind it inline could just be as much complexity. So it determines whether you want to use multiple different devices or security tools, or you want to have all-in-one encompassing. Thing is, you do have one point of failure if your firewall does go down. So that is one thing that you should take into account. Let's see. It just goes over when you're doing layer 3 mode, you can do the routing piece. You can either do IPv4, 6. You can also do DHCP, right? You can have distribute public or private IP addresses within your environment, which is really nice. And another advanced tool or functionality of the layer 3 mode. So when you go into the layer 3 mode, that interface, you're pretty much trying to use the full capacity of the product itself, right? You can also do ARP entries, so address resolution protocol, right? Also reverse as well. You hit a MAC address, give me the IP. You hit an IP address, give me the MAC. I'm trying to reroute and find out where things should be sent out. Management port, permitted IP addresses. Okay, here. Assigning IP addresses to the interfaces themselves, and then sub-interfaces, virtual interfaces. This should be very common knowledge based off of CISS 341 if you've taken it. And let's continue on. So virtual routers, I'm not going to spend too much time on virtual routers either. A little out of scope for this class, but we'll go into the basics that are needed to be able to configure and understand the Palo Alto firewalls. So just basics, right? There's different dynamic routing protocols, including OSPF, version 2 and 3, RIP v2, BGP v4, and then there's multicasting routing protocols, including PIM-SM and then -SSM. Now, a virtual router is a firewall function that participates in layer 3. The routes the firewall obtains, so you can actually utilize the firewall as a layer 3 router, and that's why it kind of briefly discuss virtual routers and the different routing protocols, because you can actually configure the routing protocols within the firewall to act as your router. Okay. However, the firewall uses Ethernet switching to reach other devices on the same IP subnet. Let's see, and you kind of go into the configurations here. It's a lot more. If you've taken the Cisco class, you're actually going into the CLI. You're opening up the virtual interface. You're typing in the IP address associated with it, all via like syntax. This is more of a user interface, GUI interface, where you can just click on the interfaces and type the IP addresses associated with them. The distances right here, that kind of determines the best path, best route to take, the administrative distances. But let's see, let's continue on. This kind of goes just through how to configure routes and different interfaces, right? An administrative distance field enables you to override global administrative distances values configured on the router settings. This metric helps find the virtual router determine the best route when the same routing protocol offers multiple paths to the same destination. Multiple default routes, static routes can configure multiple static default routes. Route with the lowest metric is used. So back to this administrative distances, you can reconfigure these to force a specific route to be taken, right, based off of these metrics, like MTU size, hops, etc. Path monitoring determines if routes are usable. Firewall switches the default route during path failure, so kind of as a backup. And then we'll go here, path monitoring failure condition. These are just how to configure, and kind of gives little explanations to how the configurations. And that kind of wraps it up. We kind of talked about network segmentation, security zones, and the different interfaces on the firewall. All right. Now, let me know if you have any questions. Some really cool stuff. And yeah, with that kind of wraps up this lecture, and I will see everyone next time. Thanks.